In the context of aircraft, the high-speed theory refers to the aerodynamic principles and considerations that come into play when an aircraft is operating at high speeds. These speeds are typically encountered by supersonic or high-performance aircraft. Here are some key aspects of high-speed theory in aircraft. Compressibility. At high speeds, the density of the air becomes significant, and the compressibility of the air cannot be ignored. This means that changes in air pressure and density due to the aircraft's motion need to be considered. Compressibility effects become more pronounced as the aircraft approaches or exceeds the speed of sound, Mach 1. Shock waves. As an aircraft approaches and exceeds the speed of sound, shock waves begin to form. These shock waves are created when the airflow around the aircraft is compressed and reaches supersonic speeds. Shock waves cause a rapid change in air pressure, resulting in a variety of aerodynamic phenomena such as drag, wave drag, and sonic boom. Wave drag. Wave drag is a type of drag that occurs due to the formation of shock waves. As an aircraft accelerates through the transonic and supersonic speed ranges, the drag caused by wave drag increases significantly. Aircraft design techniques, such as using streamlined shapes and minimizing areas of high pressure gradient, are employed to reduce wave drag. Area rule. The area rule is a design principle used to reduce wave drag. It states that the cross-sectional area distribution along the length of an aircraft should be smooth and gradual, rather than abruptly changing. By adhering to the area rule, designers can minimize wave drag and improve high-speed performance. Swept wings. Swept wings are commonly used in high-speed aircraft to delay the onset of shock waves and improve aerodynamic efficiency. The sweep angle refers to the angle between the wing's chord line and the direction of the aircraft's motion. Swept wings help to reduce drag caused by shock waves and increase the critical Mach number, allowing the aircraft to operate at higher speeds before encountering significant compressibility effects. Thrust and power requirements. High-speed flight requires a significant amount of thrust to overcome increased drag forces. High-performance engines with high thrust-to-weight ratios are crucial for achieving and sustaining high speeds. Additionally, maintaining engine power and cooling systems become important considerations as aircraft speeds increase. These are some of the fundamental aspects of high-speed theory in aircraft. Designing and operating aircraft at high speeds involve numerous complex factors and considerations, including aerodynamics, materials, propulsion systems, and structural integrity, to ensure safe and efficient high-speed flight.